The question says predict all the alkenes that would be formed by dehydrohalogenation. Dehydrohalogenation means elimination reaction. Okay, elimination of hydrogen halide. Elimination or removal of hydrogen halide is what dehydrohalogenation reaction. Of the following halides, these are the halides given here. With sodium ethoxide in ethanol and identify the major alkene. First of all, we have to carry out elimination reaction of these alkene, and then we have to identify the major product in the reaction. Okay, let me take the first reactant we have. First reactant is what? 1 bromo 1 methyl cyclohexane. First of all, we can draw the structure. First reactant is that this is what? Cyclohexane. We have the cyclohexane. And you can see 1 bromo 1 methyl means both the group are attached to the one carbon. You can see 1 bromo Br is there, and this is what we have CH3 is there. Now pay attention very carefully. We have the reagent sodium ethoxide. Sodium ethoxide, this is what? C2H5, but it is ONA is there, and in ethanol it says C2H5OH is there, acting as a solvent. Protic solvent is there. Okay, it can liberate proton. If you break it from here, it will carry negative charge. Since it is having the negative charge, you can see it will be acting as a base. Okay, acting as a base. And in elimination reaction, we use the reagent that is a base. In a nucleophilic substitution reaction, we use nucleophile. Okay, now pay attention carefully. How we complete elimination reaction? In these elimination reaction, always keep in mind, from alpha carbon we remove halogen. What kind of halogen is there? Br. So keep in mind, from alpha carbon we remove Br, and from beta carbon we remove hydrogen. So you can see the dehydrobromination is there, removal of HBr, removal of hydrogen halide. Okay, so will be causing elimination reaction. Now pay attention carefully. You can see the Br is attached to this carbon, then this carbon is a alpha carbon forming. Alpha carbon. And next carbon, this is what? Beta carbon. This side also next carbon, it is a beta carbon. This side also you can see next carbon, we have the beta carbon. And keep in mind, product formed in elimination reaction depends on the number of beta carbon. Okay, if same beta carbon is there, only one product is formed. If different beta carbon are there, then different number of products are formed. Now you can see, this is beta carbon, it is CH2. This is also a beta carbon with respect to this alpha carbon. This is also a beta carbon. So you can see it is also CH2, CH2, CH2. These two beta carbon are same. Means only from here we get one product. But if you see it is CH3, this beta carbon is different from these two beta carbon. Hence we can get one product from here and one product from here. Okay, if same beta carbon is there, only one product is possible. Different beta carbon, then we get a different products. So in this reaction, how many products are possible? Two products, because we got one beta carbon and here we have different beta carbon. You can see there are two types of different beta carbon. This is what? CH2 and this is CH3 there. Okay, now carry out the elimination. Now let's say if I remove, this is alpha carbon, follow this condition, alpha carbon. From alpha carbon we remove halogen. I remove halogen, and here we have hydrogen is attached. Okay, so I remove from beta carbon hydrogen, alpha carbon halogen, beta carbon hydrogen. So you can see from here we are removing this portion. Okay, and when we remove HBr, so what will happen? You can see, to satisfy the valency of this carbon as well as this carbon, one double bond will be attached. So we got the substance cyclohexane is there, and you can see one double bond will come, and here we have the CH3 is there. Very interesting. Okay, double bond, because you can see this carbon is forming a 3 bond, means one hydrogen is present, valency is satisfied. This carbon similarly also forming 4 bond, there is no any hydrogen present. Now if I consider this beta carbon, so in this case you can see I can write here, we have CH3, so this portion I can write CH2 and H, same thing only. Okay, so from alpha carbon Br is removed, from beta carbon this H is removed, then double bond will come here, double bond in this place, to satisfy the valency. Then one product we are getting here, we have plus another product cyclohexane is there, and double bond will come here like this. Okay, you can see alpha carbon Br and beta carbon hydrogen. So double bond will come here. From here, alpha carbon Br and beta carbon hydrogen, double bond is coming here. We got two products. Now we have to identify which one is the major product. So you can see both are alkene, and to determine the stability of alkene we use the concept of hyperconjugation. In case of hyperconjugation, we have learned higher the hyperconjugation, okay, higher the number of hyperconjugated hydrogen ion, higher is the stability. Very simple concept. Now pay attention carefully. You can see this is a double bonded system. Okay, double bonded system. This carbon is a part of double bond. This carbon is also a part of double bond. Next carbon will be alpha carbon. You can see this is alpha carbon. This is alpha carbon. This is alpha carbon. Calculate the number of hydrogen attached to the alpha carbon. 3 hydrogen, 2 hydrogen, and 2 hydrogen. Total we got 7 hyperconjugated hydrogen ions. Okay, we always calculate hydrogen from the alpha carbon. Alpha carbon attached to the carbon, part of double bonded system. Now here also you can see we have the CH2 is there. This is a double bonded system. This side this is alpha carbon. This is also alpha carbon. Here we have 2 hydrogen. Here also 2 hydrogen. We got 4 hyperconjugated hydrogen ion. And as we have learned, higher the number of hyperconjugated hydrogen ion, higher the stability. So you can see in this alkene, more number of hyperconjugated hydrogen ion are there. Then we can say it is a major product, and then it will be minor product. So very interesting. You can see first one is the major, because in this case number of hyperconjugated hydrogen ions are more. Okay, so very interesting elimination reaction, removal of hydrogen halide. Move on to the next reaction. We have 2-chloro 2-methyl butane. You can see we have butane straight chain is there. So let me write this is the second one is there, butane. First carbon, second carbon, third carbon, and fourth carbon is there. Okay, it says 2-chloro 2-methyl. You can see to the second carbon Cl is also attached, and methyl group is also attached. Let's say this is the second carbon, first, second, third, and fourth. So let's say I mentioned this is Cl, and this is what CH3 is there. Okay, 2-chloro 2-methyl. Now again same reagent is there. This is what we have, CH3, CH2, it is ONA is there, ONA, and N we have C2H5, and it is OH is there. So it is acting as a base, hence causing elimination reaction. So in elimination reaction we remove alpha carbon, we remove halogen from the alpha carbon. What kind of halogen? You can see chlorine is there. So we remove chlorine from the alpha carbon and hydrogen from the beta carbon. Hydrogen from the beta carbon. So you can see this Cl is attached to this carbon, hence we can say this is alpha carbon. This is beta carbon, this is beta carbon, next carbon is what? Beta carbon. Okay, you can see number of products depends on the number of different beta carbon. You can see this is CH2, CH3. So these two beta carbon are different, but this is also CH3, CH3. These two beta carbon are same, but this beta carbon is different. So there are two different types of beta carbon. You can see one, and this is one. So total 2 products are possible. Okay, carry out elimination reaction from alpha carbon halogen. So let's say I remove from alpha carbon Cl, and I consider let's say I consider this one. So I do one thing, I can write a CH2 and H is there. Okay, from alpha carbon Cl, okay, and from beta carbon H. So you can see between this carbon we are removing hydrogen halide. So double bond will come here to satisfy the valency of these two carbon. Okay, so we got the substance, the product. You can see double bond will come here. Here we have double bond, and this is what we have, CH2 is there. Okay, this chlorine is removed from alpha carbon and hydrogen is removed from the beta carbon. So double bond is introduced here. Okay, valency of carbon is satisfied. Now let's say if I consider this beta carbon. So here we have this hydrogen is having this carbon is having how many hydrogen? 2 hydrogen. 2 hydrogen are there. Okay, we need only 1 hydrogen at the beta carbon. So you can see next time I remove chlorine from the alpha carbon and hydrogen from this beta carbon. So you can see remove. So you can see as Cl is being removed from this, from these two carbon, so you can see double bond will be introduced here. So we got next product. We have next product. It goes something like, and double bond will introduce here. Double bond is introduced here. These are the two products. Okay. Now you have to identify the major product. To identify the major product, we can again apply the concept of hyperconjugated hydrogen ions. Higher the number of hyperconjugated hydrogen ion, higher is the stability. So you can see this is a double bonded system. Okay, and next carbon is alpha carbon. This side also next carbon is alpha carbon. In this case, how many hydrogen? 2 hydrogen. In this case, how many hydrogen? 3 hydrogen. So 3 plus 2, we got 5 hyperconjugated hydrogen ion. Okay, next one is there. Here we have, this is the double bonded system. So this is alpha carbon, this is also alpha carbon. Very interesting. So you can see in this case 3, here also 3 hydrogen, here also 3 hydrogen. Total number of hydrogen we are getting 9 H plus hyperconjugated hydrogen ions. Since this alkene has a higher number of hyperconjugated hydrogens, then hence it is more stable. We can say it is a major product. We have the major product, and this will be minor product. So very interesting question is there. You can see we are carrying out elimination reaction also, and in elimination reaction you can see more than one product is possible. And then the stability of alkene is determined by using hyperconjugation. Move on to the last one. In the last one, you can see we have 2,2,3 trimethyl 3-bromopentane, parent chain pentane. You can see 5 carbon are there. 1, 2, 3, 4, and it is 5. 1, 2, 3, 4, 5. Now it says 2, 2, 3. Okay, say it is 1, it is 2, and it is 3. Okay, it is 2 and it is 3 there. So you can see 2, 2. So you can see 2 methyl group are there. We have CH3 here also. We have CH3 here also. Okay. Then it says 3 methyl. This is 3 methyl. Let me mention this is 3 methyl is the third carbon. And 3 bromo also. You can see Br is attached to the third carbon. So this is the substance we have as a reactant. You can see 2,2 dimethyl. Or you can see 3 methyl is also there. The 2,2,3 trimethyl. 2,2,3 trimethyl 3 bromo, and we got pentane. 3 bromo pentane. Okay, now we carry out elimination reaction. I remove this one because looking like I, it should not cause a confusion. Okay, now we have the reagent C2H5, it is ONA, and in C2H5OH is there, causing elimination. So what do we do? Alpha carbon, you can see what kind of halogen is there? Br. So alpha carbon Br. Okay, alpha carbon Br is there. We remove alpha carbon Br, and beta carbon hydrogen is there. We identify how many types of beta hydrogen are there. You can see for me this is alpha carbon, and next carbon you can see this carbon does not have this carbon does not have any hydrogen because in this case you can see it is forming already how many bond? 4 bond. It is already forming 4 bond, means it does not have any hydrogen. Okay, if I go this side, you can see this is a beta carbon is there. This is the beta carbon. Okay, and this is also a beta carbon. You can see alpha carbon, next carbon, beta carbon, alpha carbon, next carbon, beta carbon, and this is also beta carbon, but it does not have any hydrogen. It does not have any hydrogen. Let's carry out the chemical reaction. So in this case, what happens exactly? Let's say I remove Br from alpha carbon and hydrogen from this beta carbon. I consider this hydrogen. Then double bond will come between these two carbon. Double bond will come here. Hydrogen from here and Br from here. So the product which we get, we have the product. Okay, these are the alkyl group, and double bond will generate here. Double bond. Okay, and this is CH2 is there. CH2. Now the next product which we are supposed to get, let's say if I consider hydrogen from this beta carbon. So you can see hydrogen is attached here. So if I remove hydrogen from this beta carbon and Br from alpha carbon, so double bond will come in between these two carbon. So we have the next product. This is the double bond, and here we have the alkyl group here. This is the alkyl group is there. Okay, so this is the product we get. You can see there are two types of beta carbon, then we are getting two different types of product, and we can determine the stability of this product by using hyperconjugation. This is a double bonded system. Next carbon is alpha carbon, next carbon this side is what, alpha carbon, but you can see this alpha carbon does not have any hydrogen. Okay, it has two hydrogen. We can see this is having two hydrogen. In this case, you can see this is a double bonded system. So you can see this is alpha carbon, this is alpha carbon, and this is what, alpha carbon is there. Okay, this is alpha carbon, but it does not have any hydrogen. Okay, now calculate the total number of hyperconjugated hydrogen ions. In this case 3 hydrogen, in this case 3 hydrogen, 3 6, and this carbon does not have any hydrogen. We got 6 H plus is there. So you can see second product has more number of hyperconjugated hydrogen ions, hence it is more stable. So you can see it is major product, and we have it is minor product is there. Okay, it is the minor product. Second one is the major product. If you like this video, please share and subscribe to the channel.